Welcome back to Abra Knowledge channel. This is the updated version number V34. Came originally from V5, where we talked about how to convert the data, whatever the discrete or continuous data, whenever you have, how to convert into DPMO, sigma value, defect, yield calculation, and all that. Here, many people have requested that how to calculate from the percentage, how to calculate the PPM, how to calculate the sigma value, all that. Now I made it this video. This will be very, very helpful to you. And one more thing is this Excel, I will be sharing it. Those who comment on this, or you can write an email to me at abradknowledge@gmail.com. Right. I will keep this link here also as well. So you can write an email if you wanted to have these particular Excel assets. So let's see, there are three scenarios we already which we saw in the past, but we are going to do it one more time very, very quickly. More importantly, this is a new segment which we will be doing it now, how to convert the data into PPMs and sigma value and all that. So this is a scenario number one. Invoice processing has got 55 defects. So I'm going to key in 55. And then, so it says that the volume is 5555. And then it says that it has a 5 opportunities. That means, so this one in the discrete, there are two types. Now here, whenever you have opportunities are critical to quality and checkpoints and all that. So you can, from the control chart, you can use C chart or U chart, or it uses the following. It uses there is a distribution called Poisson distribution. Let's say quickly to this one. How to calculate yield? Very simple. Uh, this is the whatever one minus, you can keep it because we are talking about 100. So defect divided by total volume. So this is the 99 percentage is the one. And how much is the defect? It's very simple. 1 minus this value will give you a defect. And what is the PPM value for this? Sorry, DPMO value, defect per million opportunities. And as I said that since we are talking about opportunities and all that, so we are talking about defects, right? So defect per million opportunities, the formula is very simple. A number of defects into 10 to the power of 6. I'm gonna keep it 6 zeros. 1, 2, 3, 4, 5, 6 divided by number of opportunities times volume. Okay, that means 1980 is the DPMO value. What is the sigma value for this? Right? You can give equal to n norms dot s dot inversely proportionate. You can keep it like 1 minus DPM value divided by, again you can give it like 6 zeros. Instead of 6 zeros, you can also keep it like 1 the e stand for exponential 6. So if you wanted to give 6 zeros also, you can give 1, 2, 3, 4, 5, 6. Plus, we know that when you say sigma value, 1.5 we have to add as a shift, 4.3. Long term, we have to minus that 1.5. So this is the value we got. Sorry, this is the value we have got, minus 1.5, right? Correct. So that means for this process, this is the yield percentage is 99, and you have the sigma value that is 4.38. Sigma symbol, you can remember that this is the sigma symbol, right? So that means 4.38 is still long way to go, right? So let's go to the second scenario. A foundry unit has 17605, 17605, right? And then 952 defects, 952 defects. And how many opportunities? 10 opportunities like mismatch, blowholes, pinholes, and all that. 10. And all I'm doing it, I'm just extracting this formula, just paste it here. Automatically it calculated. Yield is 94, defect is 5.4, and DPMO is 5.0, 5408, and sigma value is this one. And let's go to the third scenario. 333 laptops. So this is the 333 laptop being produced, and how many 30 defects were found, and and then 7 are the opportunities, and then I'm just copy pasting here. That's it. So you can just calculate. And also whenever you wanted to change, for example, let's say defect came down from 30 to just 3, right? Sigma value will come up and DPMO value will go down. Just one, right? Automatically it got calculated. Let's say defect is only 3.4, right? And again, it got calculated. Let's say you have 1 million opportunities, 2, 3, 4, 5, 6. Right? So again, we are talking about opportunities. Let's say we wanted to keep it one, and let's say we can easily find out that whatever the value, right? So I'm just keeping the original value, 333 laptops, and 30 were defects and 7. Okay. Okay. So this is the scenario. We dealt with something called defect data. We dealt with the Poisson distribution, right? And let's come back to directly from the percentage. For example, if we know 99.99966, we all know it's a Six Sigma, right? We all know it's a 3.4 defect. Let's prove it. So defect percentage is very simple. So 1 minus, sorry, equal to 1 minus, this is the defect percentage. And then let's say that PPM, how to calculate PPM? That is very first question, right? From the percentage, how to calculate PPM? So all you have to do is equal to open bracket and then 1 minus this value, or you can directly take defect percentage also. I'm just taking this percentage into, because we are talking about, we are converting into, so how we convert into percentage, we are converting into PPM. So that means we have to add 6 zeros, 1, 2, 3, 4, 5, 6. So 3.4, we, okay. 3.4, we also know that it is a Six Sigma. Let's prove it. 1 minus DPMO value 1 the power of 6. I'm gonna keep it in order to just short form of, instead of keeping 6 zeros, I'm keeping e the power of 6 plus 1.5, like 6. And then we know that long term, this will be, this is the enough. We know it's a Six Sigma. If you just say in case if you wanted to ZLT, long term performance, you can use this also, but not widely used. But just in case if you wanted to use, you can use this also as well. Okay, so now it is calculated. For example, like what if it is only 99? That means it is only 3.8 sigma. Let's say what if it is 98? What if it is 90, right? And what if 80, just 80, right? 2.3 sigma. What if we have only accuracy of 60 percentage, 1.8 sigma? What we have accuracy of just 50 percentage, 1.5 sigma, right? Long term is almost nil, right? So I'm going to also prove this with the help of standard table, right? I'm going to take this table, copy this table, and then I'm going to keep it here and then test these conditions. For example, let's say I will take, we have already test for 99. Maybe I will take 93.3, I will take it. 93.3, we supposed to get 3 sigma, right? We got a 3 sigma. Excellent. I'm just comparing this and this because this is a DPMO. What we are calculating is PPM. There is two slight differences. That's the reason. Okay. And then let's say I will keep it 84.1 should be 2.5, right? 84.1. 84.1 is 2.5, right? Let's say 57.9. Randomly, I'm taking it. 57.9 is equal to 1.7 sigma. Perfect, right? And then let's say 99.984. 99.984, automatically it came like 5.1 sigma. Perfect, right? I hope you enjoyed this video, and please feel free to write to this one if you need to have this template. And I hope you find this very useful. Please do like, share, subscribe my channel. You have wonderful day ahead.